Hello coders, welcome to my channel. I am Aniket and today we will discuss problem cut rope to maximize product from GFG. Let's read the problem. Given a rope of length n meters, cut it into multiple smaller routes such that the product of their length is maximized. At least one cut is mandatory. So for this too, it might be possible that you can take the whole rope as it is, and then the cost of this multiplication is simply 2. But here in this question, it is specified that at least one cut is mandatory. So you have to cut this rope at least one time. So let's make it a rope 0, 1, and 2, and you cut at 1 because it is a rope of length 2, so you cut at 1. Now the you have two ropes of length 1 and 1, so if you multiply both of them, then you got 1. That's why the optimal answer for this problem is 1. Since one cut is mandatory, maximum optimal obtainable product is 1 into 1, that is 1. And for n is equal to 5, you have a number line like 0, 1, 2, 3, 4, and 5, and you want to cut this row at any index 0 to till 5. If you cut your rope here, then you can easily see that there is a 3 length rope in left side and there is 2 length rope in right side. So if you multiply both of them, you get 6, which is the optimal answer. So I hope you understand now what the question is. Now explain, now see how can we solve. This problem can be solved using partition DP concept. In this DP, we have several choices for every index. We have several choices for every index. And what are those choices? Can we cut after one position? Second choice is, can we cut after two position? And can we cut after three position, and so on. Let's make a tree diagram to visualize this problem clearly. So for n is equal to 3, let's make a tree diagram. First of all, you are at one length, and if you cut after 1, then you reach at 1. If you cut after 2, then you reach at 2. If you cut after 3, then you reach at 3. How can you find the length of the cutting? So it is very simple. For this 1 to 1, the length is simply 1 minus 1 plus 1. For 1 to 2, the length is simply 2 minus 1 plus 1. For 1 to 3, the length is 3 minus 1 plus 1. So for finding any length, you can do current minus pre plus 1. This will give you the length of the rope. I hope you understand now how can you find the length of the rope. If you cut after 1, then you can call your function to 2 length, and now for this 2 you want to find the optimal way to cut the rope. And if you cut after 1, then you reach at 2. If you cut after 2, then you reach at 3. You can't cut after 3 because if you cut after 3, then you reach at 4, and that is not optimal because the n is 3 and you can go up to 3 only. You can't go beyond 3. So I hope you understand now why this node has only two branching, 2 and 3. Similarly, here also, if you cut after two position, then you will call your function, recursive function, to 3 and want to find that how can you cut the rope optimally from this length 3. So if you cut after 3, then you reach at, if you cut after 1, then you reach at 3, and if you don't cut after 2, because if you cut after 2, you are beyond this n. That's why there is only one node, one branching for this node. And here also you will call your function from next length, that is 4, and there is no 4 for this, you are out of the range, so that's why you will return 1. We will return 1 because multiplication of 1 to our answer doesn't affect anything. That's why we return 1 when we are out of bound. Similarly, here also, if you cut after 1 from this 2, now you will call your function to this 3 length and want to find the optimal way to cut the row. So for this 3, if you cut after 1, then you reach at 3, and you can't cut after 2, because if you cut after 2, you are beyond this n. That's why you can only cut after 1 from this 3. From this 3 also, you will call your function for next I plus 1, and for this it is out of bound, that's why you return 1. In this case also, if you call this 3 for next, then you will return 1 only, 1 only. And as you can see, these 3 branches are returned, but this is not. So for this you will call your next length, that is 4, and want to find what is the optimal way to cut this length 4, and you will simply return 1. So what is, or but how can you apply the DP approach in this problem? As you can see here, there is a overlapping subproblem. You will find the value of 2 here, and you also find the value of 2 here. So that's why there is an overlapping subproblem. There is an overlapping subproblem. So we can use DP with memoization. What does DP of I store? DP of I stores what is the maximum product can be achieved if you start from I length. I hope you understand now what is the DP of I will store. It stores the what is the maximum product that can be achieved if you start from I length. So you can easily find your answer using a DP of 1. DP of 1 store what is the maximum length, maximum product achieved if we start from 1 length. I hope you understand now, but here the major thing is you can consider the whole string as a partition also. We can consider the whole string also as a partition. But according to question, there is at least one cut always. There is at least a one cut. But if you carefully see, when you are at 1 and you call this 3, then this will return 1 and the length is only 3. So it might be possible that you can return 3 as your maximum answer, because you don't cut your rope you don't cut your rope by any length. That's why the length is 3 here. So I hope you understand. How can you tackle this? This can easily tackle that, because For n is equal to 2 and 3 only, there is a n is greater than all possible partitions, and for other values of n, that is n greater than 3, it is always optimal to cut the rope. So you can easily handle this two types of n, that is when n is equal to 1 return simply 1, and when n is equal to 3 return 2. I hope you understand now how can you easily tackle this type of situations, because for other n greater than 3 it is always optimal to cut the rope. So this function will give you the cutting possibilities. And for n 2 and 3, the for n 2 and 3 it is greater than when you consider the whole rope as it is, then it will be greater than all possible partitions. That's why this function will consider that only, and you can easily tackle this. If you n is equal to 3, simply return, if n is equal to 2, simply return 1, and if n is equal to 3, simply return 2, because for 2 you can partition 1 and 1, and for this 3 you can partition 1 and 2. I hope you understand now. Now let's discuss the code, but before that please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. Here is my simple Java code where I initialize a DP for memoization, so that if we calculate any state, then we don't calculate it again in future, and we can easily use that value that is stored in DP of I. And we initialize our n as a global, which is storing the length of this n. And when n is equal to 2, simply return 1, and n is equal to 3, simply return 2, as I explained you earlier. And this n will store this n, and then I initialize my DP of n plus 1 size. Then I simply return memo of 1, which will give, it will give the maximum product if we start from one length. So int cut, whenever cut is n plus 1, then simply return 1. And if there is a already stored value in dp of cut, then you simply return the dp of cut, and initialize your answer to 0 and maximize it whenever possible. How can you find the number of length? It will give you length of the current cutting, and you can call your memo of I plus 1. It will give you the optimal way to cut the remaining row. In this way, you can easily maximize your answer and simply store your answer into DP of cut. I hope you understand my code and the intuition behind this code, how partition DP is easily solve this problem. Please hit the like and subscribe button.